this is very much like your worksheet. That one is like the one on the worksheet. Similar worksheet. So I do that one. Okay. So. Hey, this one, the region is very nice. Why the heck am I supposed to change the variables? Oh, because the integrand is bad. That's the purpose of this one. Sometimes change messes up the region, but makes us have a lot better integrand. And that's one of those questions. So the region X and Y is very nice. Very nice rectangular region right now. But I'm going to mess it up. Why? Because I can't integrate even if the region is very nice. It's a messy, very messy integration. There's a change. So if you want to take the integral of this on that region in X and Y, you will need trig identity. Then you need integration by parts twice. And then again, it repeats itself. It becomes really, really messy, really, really quick. And so that is too much of a mess. So I mess up my rectangular region to make the integrand a little better. Okay. So how do I do that? Let's choose this to be U, this to be V. So U equal to X minus Y, V equal to X plus Y. And then find the Jacobian of U and V and X and Y. And that's 1, -1, 1, and 1. So that's 2. So the actual Jacobian is going to be 1/2. Now, the integrand got simplified. Let's figure out what is going to happen to basically U and V. So the first, let's see, this is the first one. I kind of want to figure out where does that boundary go and where this boundary goes, where this boundary goes, and where this boundary goes. That's one way. You guys have seen it, right? You parameterize. First boundary is going to be X and pi. The second boundary parameterization is going to be pi and Y. And it's sort of messy. Fun part of linear, is this a linear transformation? Yeah, it's a linear transformation, right? Linear transformation. Fun part of linear transformations is that you can skip that parameterization. And in case that you have lines, linear transformation, you can skip the parameterization part of the finding the regions if you have lines. And what do you do? What do you replace it with? Each line transforms to another line, so you can just find points on those lines and transform them, and the line transforms to the line between the transformed points. So here, I go back to U and V. Sorry, guys. Again, Murphy's law. Your nose itches the worst if you wear something over it. U and V. Now, I'm transforming, let's say, what is this point? This point is the points in X and Y points, and U and V points. X and Y points, I have 0 and pi. So if I have 0 and pi, and I plug in 0 for X and pi for Y, I get U equal to negative pi. And in here, I get V equal to pi. And then this point is pi and pi. If I plug in pi and pi, I get 0. And in here, I get 2 pi. If I plug in this point, this is pi and pi. This point is going to be what? Pi and 2 pi. So I get, for U, I get minus pi. For V, I get 3 pi. And then this point is 0 and 2 pi. For U, I get negative 2 pi. And you guys tell me if I'm wrong. And for that one, I get 2 pi. Okay, so in here, the shape goes, sorry, negative pi and pi. And then negative 2 pi. Let me redraw my region. Negative pi and pi, and negative 2 pi and pi. Pi, 2 pi. And then negative pi and 3 pi right there. And then 0 and 2 pi right there. So the region changes drastically right there. And now that region changed drastically in UV plane, you have to find the bounds, basically. Let's say U bound goes from negative 2 pi to 0. Am I right? And then, so I have to find these two bounds. It would be 2 sets, basically. This seems to be, this is Y equal to X plus 2 pi. This one is Y equal to negative X plus 2 pi. That one is Y equal to X, I think plus 4 pi. This one is, sorry. V equal to, that one is V equal to negative X, like that. So those are my new bounds. Set them all up, 2 sets, dV inside, du outside, dV inside, du outside. This region 1, going du goes from negative 2 pi to pi. The region 2 goes from minus pi to 0. And then don't forget the Jacobian. And then you will have u squared sine squared v, u squared sine squared v. And then v runs from, for the first one, v runs from minus x to x plus 4 pi. For the second one, runs from u plus 2 pi to minus u plus 2 pi. And so it makes the finding the antiderivative a tiny bit better. But it doesn't do a whole lot of interesting work for us. I'm checking my, oh, wait. U plus 2 pi, U minus U plus 2 pi. And this one is from negative x to x plus 2 pi. Yeah, I think I'm okay. Yeah, I think I'm okay. That's my solution reversed the U and V, I think. Yeah, I was worried about the equations of the lines. So that is what you basically getting in there. And then the solving it, which we're gonna skip. Okay. I have a little bit of time left. Let's do this by request. What are you guys requesting?